Hello everyone. So as a continuation of redox chemistry, our today's topic is non-additivity of redox potential and calculation of redox potential by using Latimer diagram. So you may not be familiar with the term Latimer diagram. Here this is a diagram where a Born-Haber type cycle is used in order to calculate redox potential of any system by using the reference of other two systems. And here a question arises whether they can be added or not. So first of all, look at the heading of the subtopic, which is non-additivity. That means redox potential is a non-additive property. That means they cannot be added with each other. So how can we take help for other redox potential without adding them to calculate redox potential of a third system? So this topic will be discussed here. Now let us have some examples. Here we have the example of ferrous system. Ferrous consuming 2 electrons to produce iron neutral. Ferric consuming 3 electrons to produce iron neutral. On the other hand, ferric consuming only 1 electron to produce iron 2 plus. Okay, ferrous iron. And here is another example, ferrite ion, where the oxidation number of iron is +6 to produce ferric ion, where the oxidation number of iron is +3. So all the 4 redox potentials E0 values have been given here. Now with the help of any two, how can we find the redox potential of the third system? So as for example, here you find that here we have equation 1 and equation 3, where here in the left hand side you have Fe2 plus and here in the right hand side Fe2 plus. So if you add these two equations, okay, then you will get equation 2, isn't it? Because this 2 electron and 1 electron will be added to produce 3 electrons. This Fe2 plus will be cancelled by each other. So in the left hand side we shall have only Fe3 plus and in the right hand side we shall have only neutral iron. So that is actually the left hand and right hand sides of equation 2. So let us add the E0 values of equation 1 and 3 together, and what we get here, that the combination of these two are minus 0.44 plus 0.77, that is, it is plus 0.33 volts, but this 0.33 volt is not reflected here. This value is something different. So how can we take help of these two equations in order to find out the redox potential of this equation or this relationship? So let us take the help of Latimer diagram. This is the diagram where according to the oxidation number, the different different states of the metal are plotted here, and they are connected with some lines, and on the line their corresponding redox potentials are given. Actually what is given is the reduction potential according to the IUPAC convention. Now as I have said that E0 is a potential which is an electrical property. That is actually the potential difference, and it is expressed in volts. So this is a non-additive property, so they cannot be added together. So what we can add? We can, if it would have been an energy term, then we could easily add them with each other. So how can we convert this potential difference term into an energy term? So the energy term related to E0 value is the Gibbs potential energy, which is the delta Z0 value, and delta Z0 is related with E0 as delta Z0 is equal to minus NF E0, where F is the Faraday, N is the number of electrons, and E0 is the standard electrode potential. So let us take here as an example equation 1 and equation 3. Here here according to our plotting, here are equation, here according to this picture, here it is equation 2 and this is equation 1. Okay, so in equation 3, in equation 3 there is iron 3 plus 1 electron, to produce iron 2 plus, and the corresponding E0 value is 0.77. so this is written here, and here a ferrous plus 2 electron to produce iron, and the corresponding E0 value is minus 0.44. Now these two cannot be added as we have got earlier, because their addition is plus 0.33, which is not reflected here, which is actually minus 0.04. So how can we go to this value? So we have to convert them into the energy terms and add them. So delta G equal to minus N means 1 electron is involved here, F means Faraday here, and E0 is given here. So that is minus 0.77 into F. And here 2 electrons are involved, so it is minus 2 into minus 0.044 into Faraday, that is plus 0.88 Faraday. So their combination is the summation of these two delta G0 values. So we get the delta Z0 value of the third equation, that is Fe3 plus 3 electron equal to Fe, that is here for this electron. Okay, now this delta Z0 is actually equal to minus NF E0. So E0 equal to delta G divided by minus NF. So minus 3F, because 3 electrons are involved here. So 0.11 Faraday, 0.11 Faraday divided by minus 3 Faraday. So it produces the result minus 0.04 volts. So this is the way how we can use the Latimer diagram in order to find out the redox potential of a system with the help of other two systems. Let us discuss another example here. Here the Latimer diagram of copper system are given, where the three oxidation states of copper, 2 plus, 1 plus and 0 are given here, and they are connected with their corresponding E0 values here. So by pausing the video you can calculate it yourself. Okay, now if you have paused the video and come back, then tally your answer with the follow-up. See, this is the system copper 2 plus plus electron copper. This is system 2 to system 1. Next one is system 1 to system 0. Okay, and the redox potential of both the values are given here, and if we add them we shall get just simply 0.65. okay, but we cannot do this, so we have to convert them into its free energy term. So this is minus 1 F E0 and this is also minus 1 F E0, resulting in first one minus 0.15 Faraday and the second one minus 0.50 Faraday. Now we add them, and what we get, let's discuss to the equations first. Copper plus and copper plus are cancelling each other. These two electrons combine each other to produce 2 electrons. Here copper 2 plus left alone, so it is copper 2 plus, and here neutral copper is also left alone, so this is copper. So only copper plus and copper plus are cancelling each other, other terms are left alone. So the final equation, copper 2 plus 2 electron equal to copper, that is we can get system 2 to system 0 directly. Okay, so their combined free energy is minus 0.65 Faraday. So what should be the E0 value? Look, the E0 value should be minus 0.65 Faraday divided by minus NF. Here 2 electrons are involved, so minus 2F is dividing the term minus 0.65 F, and that is producing the result plus 0.33 volt, which is reflected here. Okay, so that's all about the Latimer diagram and how we can calculate the redox potential of a system with the help of other two systems of the same category. Same category means same metal, and you can do the vice versa also. That means with the energy terms also you can calculate the redox potential, or with the help of redox potential you can calculate the free energy terms also. Okay, so that's all for today. Thank you very much.